All right, here we go, guys. All right, so we are in section 4.1. This is day 2. Today we're actually going to graph the parabola ourselves. I know at first it's going to feel like a laundry list of steps, but I'm telling you, the more you practice, the better you're going to get, the more repetitive it's going to become, and it's going to become like a routine, all right? All right, here we go. So remember, a quadratic equation or function is a degree 2 equation. What does it mean to be a degree 2 equation? It means the highest exponent on a variable is 2. So we're going to be working with all of these x squared equations, okay? The graph of a quadratic equation is a parabola, a U-shaped graph that has symmetry. If you were to cut it in half, the left and right side would match. All right, we're going to work with a quadratic equation that is in standard form. It comes in other forms, just like a straight line did. We're only going to work with standard form right now. So standard form of a quadratic equation or function looks like this. Y equals ax squared plus bx plus c. Where a, b, and c, guys, they're going to be replaced with numbers, all right? And they're going to be important to us. We're going to use those numbers, so we're going to want to be able to recognize who's a, who's b, and who's c. All right, we saw yesterday that a parabola can either open up or it can open down. If the a, the number in front of x squared, is greater than 0, which means it's a positive number, then we know the parabola is going to open up. And it's going to look something like that. If a, the number in front of x squared, is less than 0, which means it's a negative number, then we know the parabola is going to open down. And it's going to look something like that. That's always nice because you should have a visual as to what that parabola is going to look like before you even start graphing it. So if it's supposed to go up and your parabola is going down, you can catch your own mistake and say, wait a minute, that's got to be wrong. This parabola is supposed to go up. All right, the most important point on a parabola is the vertex, that highest or lowest point. So when we start graphing a parabola, that's going to be one of the first things that we do, is let me get that vertex. Let me find that really important point. So lucky for us, the vertex, it's just a point. It's x and y. There's a formula that we're going to be able to use that will always find the x coordinate of our vertex. And the formula says that the x coordinate of your parabola will always equal the opposite of b. And remember, b is always the number in front of x, divided by 2 times a, and a is always the number in front of x squared. So we're going to use those numbers to help us find our vertex. We don't need c, though. C doesn't help us find the vertex. All right? Unfortunately, though, there's no magic formula for the y-coordinate. To get the y-coordinate of your vertex, you just have to take the number you got here for x and plug them into the actual equation they gave you. So the y is just going to equal whatever you get when you plug the x coordinate of your vertex into the equation. So guys, I'm going to warn you. There's lots of plugging in. Take this x value, plug it in, see what comes out. Now take this x value, plug it in, see what comes out. So I know it's a little tedious with all that plugging in. But if you have a calculator, awesome. It'll do all the work for you, all right? Except your phone. Don't use your phone calculators. They're terrible. All right, here we go. We're going to do this one. We're going to graph this from scratch. Give you a second to write any of that down. What's that?
I said, Mrs. Hardy, a second to breathe.
I know, I do. Selfishly, I catch my breath here. All right. Okay. All right. All right, so we are going to be graphing quadratic equations in standard form, right? So a is always the number in front of x squared, b is always the number in front of x, and c is always the number at the end by itself. So if we have to graph this quadratic equation, a is assumed to be 1 here, b, the number in front of x, is -2, and c is 3. I think it helps to kind of identify them right away because you're going to have to use some of those numbers. All right, does this parabola open up or down? Well, if a, the number in front of x squared, is positive, we know the parabola is going to go up. So we already have a visual as to what this parabola should end up looking like, okay? All right, let's do it, guys, let's find that vertex, the most important point. So to find the x-coordinate of our vertex, we're going to use that formula that says x is equal to the opposite of b divided by 2 times a. Write that formula down in a really special place because you're going to use it all the time. All right, so who's the opposite of b? If we said b is -2, then the opposite of that is 2. Then we're going to divide it by 2 times a, which is 1. Well, guys, 2 times 1 is 2. 2 divided by 2 is 1. So now you know the x-coordinate of your vertex is when x is 1, okay? Now, to find the y-coordinate of our vertex, we have to take 1 and plug it into this equation, 4x, and see what y value comes out. So if I plug it in, y will equal, I plug 1 in, I square it, write it down just like I do, and then -2 times 1, and then +3. If you plug that into your calculator exactly the way I just wrote it and hit enter, it does the entire thing for you. So 1 minus 2 is -1, plus 3 is 2. So now you know the y-coordinate of your vertex is 2, which makes your vertex the point 1, 2. So as soon as you start finding out these pieces of information, put them on the graph. Start building the graph. So put your vertex on the graph, right 1 and up 2. There it is. Okay, let me pause. I didn't ask this yet. Thumbs up that you guys hear and see me okay and everybody's hanging in and we're okay? All right, here we go. All right, the next thing they want you to find is they want you to draw that AOS, that axis of symmetry, which is a vertical line that cuts our parabola in half and passes right through our vertex. So go to your vertex and draw a vertical line straight through it. Now it's supposed to be invisible, so I always draw a dashed line. And the only thing that line is doing is it's making sure that everything on the right side matches the left side. It's trying to keep both sides even, if you will. All right, now they want you to write the equation of that axis of symmetry. Remember, the axis of symmetry, it's a vertical line. And vertical lines are always x equals some number when you write it as an equation. And what is the x-coordinate that never changes on this line? 1. Remember, your AOS and the x-coordinate of your vertex should match. So technically, this formula, the opposite of b over 2a, not only does he find the x-coordinate of your vertex, but he also finds your AOS. He does 2 things. He finds both of them. All right, here we go. So now we need more points to create this U-shaped graph. So guys, we're going to go back to like straight up elementary school graphing. We're going to make a chart. We're going to pick x values, we're going to plug them in, and we're going to start creating points to make up this graph. So what I want you guys to do is take your vertex, because he counts as one of the points on our graph. I want you to put him in the middle box. Right, we already know the vertex is 1, 2. Now the problem with quadratic equations is they're x squared equations. So when you start plugging x values in, the numbers that come out get pretty big pretty fast because we're squaring them, right? So I don't want you guys having to graph y values like 83 or 122. So what we're going to do is we're going to try to stay as close to the vertex as possible. So you're going to pick 2 x values to the right of your vertex and 2 x values to the left of your vertex. So guys, right now our vertex is at 1, 2. So pick 2 x values to the right, which would be 2 and 3 are the next ones. So 2 and 3. And then pick 2 x values to the left. So that would be 0 and -1. And I want you to fill them in just like that because it'll help with the whole matching and the whole symmetry. So I want your box to be in numerical order. -1, 0, 1, 2, 3, with your vertex being right in the middle. So now the beautiful part about the parabola and the fact that it is symmetric, you have a choice. I can work with 2 and 3, plug these numbers in, and then just match the ones on the other side of my vertex, or I can plug in -1 and 0 and then just match it to the 2 and the 3, because everything on either side of this vertex is going to match. So it's kind of like a personal choice. Do you want to work with 0 and -1 or 2 and 3? It's your choice. I'm going to pick 2 and 3 just because they're both positive. So now what I'm going to do is I'm going to take x is 2 and I'm going to plug 2 into the equation and see what y value comes out. And I like to do it in order. Do the one right next to your vertex. So now y equals, I plug in 2, I square it, I minus 2, I plug in 2, and I add 3. All right, so if we plug this right into our calculator and hit enter, 4 minus 4 is 0, plus 3, 3 comes out. So that means the point 2, 3 is on this parabola. So plot it. Right 2 and up 3. So guys, you see how this point is one space away from the AOS? That means one space away on the other side, there's a matching point. So that means anybody who chose to plug 0 in would have also got a 3 to come out. It's gonna match on both sides of the vertex because it's symmetric. All right, now I'm gonna plug 3 in and see what number comes out. I'm gonna plug 3 in and square it, minus 2 times 3, and then plus 3. Plug that right into your calculator and see what number comes out. It's gonna be 9 minus 6 is 3, plus 3 is 6. So that means the point 3, 6 is on your parabola. So plot it. Right 3 and up 6. So you see how this dot is 1, 2 spaces away from the AOS? So that means 1, 2 spaces the other way, there's a matching point. That means anybody who plugged negative 1 in would have also got a positive 6 to come out because it's gonna match on both sides of the vertex. And now you just connect your 5 dots and there's your U-shaped graph. That's normally all I require you guys to get is a vertex, 2 matching points, and 2 matching points. Because you'll notice the next 2 get pretty big. So the y-coordinate gets pretty high. All right, how did that guys feel? Everybody okay? All right. Guys at home, can I get a thumbs up? I know it's a lot, but I'm telling you, the more you do it, the more routine it's gonna be. All right, now they just asked you a bunch of little questions about the graph. They wanna know, does this parabola have a max or a min? Well, guys, this parabola is going up, so I'll never really know its max or how high it's going because it's going on forever and ever and ever and ever all the way to infinity. But I can definitely see that right there, that vertex is an absolute lowest point, which means this graph has a minimum but not a maximum. All right, they want to know the y-intercept. There's 2 things you can do. If I look at my graph, I can clear as day see that it crosses the y-axis right there at 0, 3. So I know the y-intercept is 0, 3. But not every parabola that you graph, not every one of your 5 dots, there's no guarantee that one of those five dots is the one that crossed over the y-axis. So sometimes you'll graph a parabola, but the y-intercept isn't there. You didn't cross over the y-axis. So you can't guess. You're going to have to calculate it, but it's really easy. If you're a y-intercept, that means your x-coordinate is 0. So all you have to do to find a y-intercept is let x be 0 and plug 0 into the equation and see what number comes out. I promise you, every time you plug 0 in, the number that comes out is the y-intercept. And watch, if you plug 0 in, 0 squared is 0, negative 2 times 0 is 0. 0 plus 3 is 3. It's 3, I promise you. Because on tonight's homework, they're going to give you a quadratic equation, and then they're just going to ask you to find the y-intercept. You don't have to graph it. All you have to do is take the equation and find its y-intercept. So all you'd have to do is plug 0 in and see what number comes out. All right, the x-intercepts, or the roots, whatever you want to call them. This parabola does not cross over the x-axis, so you would just put none. All right? Well, who's the domain? What x values live on this graph? What did I say the domain of a parabola is always going to be? All real numbers. Eventually, every single x value will live on this graph. And then last, what's the range? What y values live on this graph? Well, I can see all the y values are going to be up here. The smallest y value is 2, and then all the other y values are bigger than it. So that's the y values where y is greater than or equal to 2. All right, we still okay, guys? Everybody's good? Yeah.
Oh, I have one question. Wait, how can you tell between which is maximum and?
So every time it opens up, you won't know the high point because these go on forever, but you'll definitely know the low point. So an opening up parabola always has a min. And then if a parabola opens down, I'll never know how low it goes. I'll never know the minimum because it goes on forever. But I definitely know the highest point is right there, and that's a max. So parabolas that go up have mins, and parabolas that go down have maxes. Okay? All right, let's try another one, because I'm telling you, this gets easier the more you practice it. All right, here we go. Ready? All right, so number 2, they ask you to graph f of x equals negative x squared plus 6x minus 8. If you're somebody who cannot stand f of x, then cross f of x out and put a y in its place and turn it back into an equation instead of a function. It means the same thing. All right, so remember, we are graphing quadratic equations in standard form like this. So in this problem, A, the number in front of x squared is negative 1. B, the number in front of x is positive 6. And C, the number by itself is negative 8. All right, they want to know, does this parabola have a graph that opens up or down? If A, the number in front of x squared is negative, we know it's going to go down. So now we have a visual. If our parabola doesn't end up going down, we know we did something wrong. All right, let's do it. Let's get that vertex. The x coordinate of our vertex, we'll use the formula. X equals the opposite of b divided by 2 times a. So who's the opposite of b? If we said b is 6, the opposite of that is negative 6. Divided by 2 times a, which is negative 1. Well, guys, 2 times negative 1 is negative 2. Negative 6 divided by negative 2 is positive 3. So now we know positive 3 is the x-coordinate of our vertex. Now we're going to have to plug 3 in to see what number comes out as the y-coordinate of our vertex. So y will equal. Now, guys, be careful. This x is the only thing being squared. You're not squaring that negative sign. So make sure that negative sign stays on the outside of the parenthesis because he's not part of what we're squaring. We're only squaring whatever number we plug in for x, which is 3 in this case. So make sure it's on the outside. All right, and then it's going to be plus 6 times 3 and then minus 8. Plug that directly into your calculator, hit enter, and it does the whole thing for you. That's going to be 9. That's going to make it negative 9. Plus 18 is 9 minus 8 is 1. So now you know 1 is the y-coordinate of your vertex, which makes your vertex the point 3, 1. So the minute you start finding information out, guys, put it on the graph. Write 3 and up 1. Give yourself a dot. There's your vertex. Okay. Now they want you to draw the AOS, that invisible vertical line that's going to cut your parabola in half and go straight through your vertex. So go to your vertex and put a vertical line straight through it. And again, all that does is help keep this side the same as this side. It kind of keeps it even. All right, what is the equation of that AOS? It's a vertical line, so it's x equals, what is the x-coordinate that stays the same? 3, right? They should match. The negative b over 2a, he finds the x-coordinate and the AOS for you. All right, so guys, we're moving. Now we just want to create more points to create that U-shaped graph, right? So take your vertex, put it in the middle of your chart, 3, 1. Then I want to pick 2 x values to the right, which would be 4 and 5, right? Because right now I'm at x is 3, so 4 and 5 would be next. And then I want to plug or pick 2 to the left, which would be 2 and 1. And I'm telling you, for matching purposes, make sure they're in numerical order. 1, 2, 3, 4, 5. All right, so now you're going to pick. Do you want to plug in 1 and 2 and then match it to the 4 and the 5? Or do you want to plug 4 and 5 in and match it to the 1 and the 2? Well, I don't know about you guys, but I'd rather work with 1 and 2 because they're smaller and easier. So now, right next to the vertex, I'm going to plug the 2 in first and see what comes out. All right, so, the negative sign is on the outside. I plug in 2, I square it. I am going to add 6 times 2 and then minus 8. Plug that right into your calculator and it'll do the entire thing for you. That's going to be negative 4 plus 12 is 8. 8 minus 8, that's going to get you 0. All right, so now I know 2, 0 right here is a point on my parabola. So you see how it's one space away from the AOS? That means one space away on the other side, there's that matching point. So anybody who chose 4 would have also got a 0 to come out because they're going to match on both sides of the vertex. All right, now let's plug in 1 and get our last couple points. Y equals the negatives on the outside, 1 squared plus 6 times 1, and then minus 8. Plug that directly into your calculator, hit enter, and it's going to be negative 1 plus 6 is 5, 5 minus 8, negative 3. So that means the point 1, negative 3 is on your parabola. 1, negative 3. All right, and you see how this is 1, 2 spaces away from the AOS, so 1, 2 spaces away on the other side is that matching point. So that means anybody who chose 5 would have also got a negative 3 to come out because they're going to match. All right, and then give me your best parabola. Okay, thumbs up, how did that feel? Everybody okay? You okay? Everybody at home, thumbs up, we're hanging in. I know it's a lot, you're doing great. All right, now they've asked us to answer these questions. They want to know, does this parabola have a max or a min, a high or a low point? Well, guys, this parabola is going down. So I'll never know the minimum, the lowest value, because it's going to go on forever, all the way down to negative infinity. But I can clearly see that this is definitely the highest point on the graph, so it has a max. All right, the y-intercept. Well, guys, technically, the point where the graph crosses the y-axis, it looks like my sketch right here is crossing right about there. But if it's not an actual dot, you can't guess. We're going to have to calculate it. So how are we going to find the y-intercept? We're going to plug x equals 0 in. Every y-intercept has an x-coordinate of 0. So if I plug 0 in, it's going to be the negative 0 squared plus 6 times 0, and then minus 8. Guys, 0 squared is 0 times a negative is still 0. 6 times 0 is 0. 0 plus 0 minus 8, it's negative 8. Which is what my little arm looks like it's heading towards. All right, what about the x-intercepts, the roots? Where does it cross the x-axis? It looks like it crosses it 2 times, right here and right here. 2, 0, and 4, 0. How they look in this greenhouse? Anybody looking? Okay. Okay, I'm making sure. I feel like I'm flying here. Okay. The domain. The domain is all real numbers. Eventually, every single x value on this graph is going to live on this parabola. Because I can just plug more and more x values in all the way. The range, though. The y values, it looks like they're all down here going to negative infinity. But I can clearly see that the highest y value on this graph is positive 1. And then all the other y values are smaller than. So that would be y's that are less than or equal to 1. All right. How do we feel? Okay? Yes? All right, so we only have 5 minutes left, so I don't think I have time to do the last example. I just want to find the vertex with you up to that part, and then I'll stop. And then you can look at the rest of it all filled in on your notes because it's just a little bit different. I just want you guys to see how you find the vertex when it looks a little bit different.
This is very difficult to teach on this, like virtually.
Yes.
Getting very difficult.
Especially if they don't have the notes printed out. Like, I feel like it's terrible for them because it's just way too much writing.
Yeah.
All right, so let me just at least find the vertex of this one with you guys, and then we can go. So now we're asked to graph f of x, and again, if you don't like f of x, put a y, make it an equation instead of a function, equals 3x squared minus 2. So guys, it still has this ax squared piece, which means it is a quadratic equation. The problem is it doesn't have a bx term. It goes from the ax squared to the c, which is fine. Sometimes they're not going to have a bx, and sometimes they're not going to have a c. But they will always have the ax squared part, okay? All right, so in this problem, a, the number in x front of x squared is 3. B, the number in front of just x is 0 because there aren't any x's in this problem. And then c is -2. This parabola will open up because the a value is positive. All right, now let's find the vertex. So we'll find the x-coordinate by using the formula x equals the opposite of b divided by 2 times a. So when you go to do the opposite of b, guys, there's no such thing as a positive or -0. So if b is 0, the opposite of that is still 0, divided by 2 times a, which is 3. 2 times 3 is 6, but guys, it doesn't matter. Because 0 divided by any number, whether it was positive, negative, big, or small, it's always equal to 0. So the point is, when the b value is 0, the x-coordinate of your vertex will also always be 0, okay? And then you just got to plug 0 in to see what number comes out. So y will equal 3 times 0 squared minus 2. Plug that in. 0 squared times 3 is 0, minus 2 is -2. So that means your vertex is the point 0, -2. So put it right on your graph, right there. So it also means that your vertex also counts as the y-intercept because it's directly on the y-axis. All right? Well, I'll keep going as long as the bell lets me. I'm going to put my vertical line right through it, my AOS, which is the line x equals, what's that x coordinate that's not changing? 0, right? Because they're going to match. Then I would put 0, -2 in my chart. I would pick 2 to the right, 1 and 2, and 2 to the left. And then I would start plugging stuff in, and I'll stop there, okay? All right, so guys, on your notes, when I send you a filled-in picture, I do every day on your Google Classroom, I send you pictures of the filled-in notes. This last problem will be finished for you guys to look at and see if you did correctly. All right? You do have a homework tonight on quizzes. It's 15 questions, guys, but it's multiple choice, and it's quick. You're not graphing all of them. Some questions are just, here's the equation, find the vertex. Move on to the next question, okay? All right, that homework is due tomorrow night. Delta Math from yesterday is due tonight. I hope that's okay, guys. Reach out to me if you have any questions, and I'll see you guys tomorrow. Thanks for hanging in.